Hey everybody, welcome back to my guest room. Today we're going to be doing class L, which we're going to be talking about the unit circle. So there's my screen, class L. So pretty much we'll talk about special angles again, and then the unit circle. And actually, let's start off with the special angles. So I'm going to draw the two special triangles again. And this time I'm going to be very specific about which way or what kind of sizing I use on them. So both for the 45, 45, 90 triangle, or the pi over 4, pi over 4, pi over 2 triangle. Let's write both of those. So for this triangle, which I'll try and draw relatively nicely here. We know that these sides are always the same, and this side is root 2 times it, but I always want my hypotenuse to be 1 here. So I'm going to make this 1. This is root 2 over 2. This is root 2 over 2. That's 45 degrees, or pi over 4 radians. This is also 45 degrees, or pi over 4 radians. And then we'll do the same thing for the 30, 60, 90. So for the 30, 60, 90, same idea, or the pi over 6, pi over 3, pi over 2. You can either draw it this way. I mean, there's like lots of different ways you can orient it. Where this is the 30-degree angle, this is the 60, this is the 90. We want the hypotenuse to be the largest side, but we also want the hypotenuse to be 1. So instead of making this 1 and this 2 and this root 3, I'm going to make this 1, this 1/2, and this root 3 over 2. You can check the Pythagorean theorem if you like, just in case anyone's curious. Root 3 over 2 squared plus 1/2 squared is square root of 3 squared is 3, 2 squared is 4, 1 over 2 squared is 1 over 4, 3/4 plus 1/4 is 4/4, which is 1, which is equal to 1 squared. So yes, this checks out. A squared plus B squared equals C squared. I feel like I look very dark in this video here. I mean, it's not a big deal, but I could brighten. Let me brighten this video up just a little bit. Sorry, I know it's annoying, but there, that's a little bit better. I mean, it doesn't really matter. And then just to kind of show this again, sometimes we draw this like this, sometimes we reorient it. So like the 60-degree angle is the one that's kind of in the lower corner. So we're 60, 30, and then this is the right angle. And now opposite the 30-degree side is the smallest side. Opposite the 90-degree angle is the biggest side, and opposite the 60-degree angle is the medium side. Okay, so the reason I'm talking about these is because we're going to put them on the unit circle essentially. So when we say unit circle, what do we mean? Well, what we mean is a circle whose radius is 1. So it's a circle. It is centered at the origin. Zero, 0, with a radius of r equal to 1. We know how to find the equation for this circle, right? The equation of the circle would be x minus 0 squared plus y minus 0 squared equal to 1 squared. Or more simply written, x squared plus y squared equal to 1. That is the equation of the unit circle. Great. So in all these pictures here, this will be the origin right there where the x and the y axis cross. I'm not going to write x and y over here every time. Did you want to point a few things out about this unit circle? So it's got a radius of length 1, meaning that if I go 1 in the x direction, this point here will be the point 1, 0. Similarly, if I go 1 in the y direction, this will be the point 0, 1. If I go 1 to the left instead of in the positive x direction, to the negative x direction, I'll be going -1, 0, my left point. And down at the bottom here, 0 in the x direction and -1 in the y direction. A few other things to point out. We're gonna start labeling things, and I'm gonna pick out lots of these. This angle here, we think of this angle being 0 degrees or 0 radians. Up here, we've got theta equal to 90 degrees or pi over 2 radians. Over here on the left, we've gone halfway around the circle. It's 180 degrees or pi radians. Down here, it's 270 degrees or 3 pi over 2 radians. If you make a full revolution, you get all the way around to theta equal to 360 degrees or 2 pi radians. A couple other things to say about this. Some terminology I use, which is not standard. I often call these 4 points the 4 corners of the circle, which I know is a terrible thing to say because circles don't have corners, but it's just something I say. You can also say the top, bottom, left, right, or the north, south, east, and west of the circle. So lots of different ways to say it. Let's talk about how some of these angles we've talked about live on the unit circle. And actually, we'll get there in a minute. But here's what I want you to know about the unit circle. Yeah, do I want to say this first? It's kind of a back and forth. Yeah. So yeah, let's go ahead and say this first. So let's say we draw some angle theta in the standard position, meaning measured counterclockwise from the positive x-axis. And here's the positive x-axis. Oh, I know what I want to say in the previous page. Sorry. One more thing. Just as a reminder, if this is the xy coordinate system, right? X is positive, x is negative. So on the right-hand side here, right over here, this is where x is positive. Over here, this is where x is negative. So the x coordinate is negative on this side, positive on this side. Similarly, down here, this is where y is negative, right? Y coordinate is negative. Up here, and then I've kind of, I wrote x bigger than y. I should say x bigger than 0. Sorry. And up here, and my picture's gotten a little bit messy here. Y is positive. Y is positive. So above the x-axis, y is positive. Below the y-axis, y is negative. Left of the y-axis, x is negative. Right of the y-axis, x is positive. Okay. So let's say we had any old angle drawn in standard position. So let's say we went, I don't know, here's our terminal ray right about there. Not quite 45 degrees. We're just going to call it theta. And we know that this distance from the origin to this point here is 1. Right? That's the very definition of the unit circle. The distance from the origin to any point on the circle is 1. So that means this length of this segment here is also 1. Now we're going to drop a perpendicular. Always to the x-axis. We're going to call, there's a right angle there. And then we're going to say in this triangle, this bottom side here has a length of x because of the horizontal distance. This vertical side here is a length of y. If you go over x and up y, the point you're at is x comma y. So now let's define, or not define so much as revisit the 6 trigonometric functions. So in this picture, I'm just going to write what cosine, sine, etc., everything is. So let's see. Sine of theta is the opposite over the hypotenuse, which is y over 1, which is just y. Cosine of theta is the adjacent over the hypotenuse, which is x over 1, which is just x. Tangent of theta is the opposite over the adjacent, which is y divided by x. Fun fact, and this is worth noting here, let me grab my other pens. Another way to think of tangent of theta, which you might have already been doing, is, oh, tangent of theta is y divided by x, which is just sine divided by cosine. So people like to think of tangent of theta as sine of theta divided by cosine of theta. And then the reciprocals, cosecant of theta is going to be 1 over y. You can also say it's just 1 over sine of theta, but really it's the reciprocal of sine of theta. Secant of theta is the reciprocal of cosine. It's going to be 1 over x. or if you prefer, hypotenuse over adjacent. And finally, cotangent of theta, instead of being opposite over adjacent, it's adjacent over opposite. So it's x over y, which again is just the reciprocal of tangent. I will also point out, people like to think of cotangent of theta as cosine of theta divided by sine of theta. So why does this matter? Well, it matters because it allows us to then kind of think about trig functions of angles that are not necessarily some of the nice angles we've talked about, or like we were talking about in class on Thursday, how to find sine, cosine, tangent, etc., of angles that are larger than 90 degrees. So we're going to draw some nice pictures here. We're going to start off with, so let's start off with the following. We're going to look at angles whose reference angle is 30 degrees or pi over 6 radians. And I don't use your radians, I kind of just accidentally do it there. Happens. Okay, and then I'm going to try and draw these looking relatively nice, so I'm going to use a ruler. So, okay, so 30 degrees, I don't know, 30 degrees, about like that. Sure, that's about right. And now I'm really going to try and be precise here. And then I'm going to get that, and let me just be extra precise. It's nice to draw a nice picture sometimes. We'll do that, and we'll do that. Cool. Okay, so this first angle, 30 degrees. There's my first reference angle, or pi over 6 radians. So here I'm going to say theta equals 30 degrees, which equals pi over 6. Now, for our special triangle, in fact, let me draw it again here. Here's my 30, 60, 90, right, triangle, where the sides are 1/2 over here, 1 over here, and root 3 over 2 here. Now you might understand better why I wanted my hypotenuse to be a length of 1. Because if I drop this perpendicular, now this triangle that I'm drawing, this 30, 60, 90 triangle, the hypotenuse in my unit circle, where the radius is 1, all of the hypotenuses are going to be a length of 1. So this hypotenuse is a length of 1. This base is a length of root 3 over 2. This height is a length of 1/2. And this point here, the x and the y coordinate are, I've kind of written this in the exact wrong spot here. The xy coordinate is root 3 over 2 comma 1/2. And so we can see from the idea of the unit circle that we had on the page before, sine of theta is just the y coordinate. Oops, sorry, I got a little blurry there. Sine of theta is just the y coordinate. Cosine of theta is just the x coordinate. So if I think about this, and I'm just going to write sine, cosine, and tangent here, just to be a little bit, I don't know, quick, there's a better word, efficient. So here, looking at this, I can see that sine of 30 degrees is going to be 1/2. Cosine of 30 degrees is going to be root 3 over 2. And tangent of 30 degrees is going to be 1/2 divided by root 3 over 2. Whenever you have fractions divided by fractions, the denominators are the same, the denominators then be canceling out. And you just get 1 over root 3, which is root 3 over 3. Okay, now here's what's super cool about this. Every other angle whose reference angle is 30 degrees. I'm going to draw them right now. So we've got, sorry, can I draw them? Maybe. We've got 150 degrees over here. And let's draw them in red. And let's draw them in blue, actually. Sorry. So here, theta is 150 degrees, or 5 pi over 6 radians. This point here has the same height as this point, so the y coordinate is the same. But this point here, instead of having a positive x coordinate, it's the same distance, but to the left, so it's a negative x coordinate. It's going to be a negative root 3 over 2. So this reference angle of 30 degrees corresponds to an actual angle of 150 degrees. And then we can see that, okay, well, using the same idea that sine is the y coordinate, cosine is the x coordinate, sine of 150 degrees is going to be positive 1/2. Cosine of 150 degrees is going to be negative √3/2. And tangent of 150 degrees is going to be negative √3/3. Because it's going to be 1/2 over negative √3/2, which will reduce to the same thing as this, it will be negative. And then the same thing persists for any other angle whose reference angle is 30 degrees or pi/6 radians. So if I go into quadrant 3 here, well, now this point here has the same x coordinate as this point here. So the x coordinate is negative √3/2. And the y coordinate, instead of being positive 1/2, now we're down here, it's going to be negative 1/2. The angle here is 180 degrees plus 30 more degrees. So the angle here is going to be theta equal to 210 degrees or 7 pi/6 radians. So if I wanted to find sine, cosine, and tangent of 7 pi/6, I'll use radians this time. Sine of 7 pi/6 is negative 1/2. Cosine of 7 pi/6 is negative √3/2. And tangent of 7 pi/6 is positive √3/3. Finally, if we go all the way around to quadrant 4, so I should get the ruler. The last time it wasn't super straight. So now this last one, again, having a reference angle of 30 degrees, the reference angle being the angle we measure with the x-axis. So now this point over here has a positive x coordinate of √3/2 and a negative y coordinate of negative 1/2. The angle here, of course, is theta is either 11 pi/6 in radians or 330 degrees in degrees. Same deal. So sine of 330 degrees is negative 1/2. Cosine of 330 degrees is positive √3/2. You don't have to write the positive signs. I'm just being emphatic about the fact that this one's negative and that one's positive. And finally, not finally, tangent of 330 degrees or 11 pi/6 radians is negative √3/3. Okay, so here's the takeaway that I want you all to see. We're going to see this 2 more times with the other kinds of angles. Any angle that has the same reference angle has the same trig function values up to a sign difference, SIGN, not SINE. So whether your angle is 30 degrees, 150 degrees, 210 degrees, or 330 degrees, or pi/6, 5 pi/6, 7 pi/6, or 11 pi/6 radians, no matter what, all of the sign values are the same, except some are positive and some are negative, but they're all either 1/2 or negative 1/2. All the cosine values are the same, except some are positive and some are negative. All the tangent values are the same, √3/3, except some of them are positive, some of them are negative. That's kind of the whole story here for any of these nice angles that have the same reference angles. So the reference angle is the same, the trig functions have the same value, you just have to determine whether it's positive or negative. And it really ends up depending on what quadrant your angle falls in. First quadrant, everything's positive. Second quadrant, the sine one is positive. Third quadrant, tangent ends up being positive. Fourth quadrant, cosine ends up being positive. And it's just because it's based on x and y. In the first and fourth quadrant, x is positive. In the second and third quadrant, x is negative. In the first and second quadrant, y is positive. In the third and fourth quadrant, y is negative. Okay, let's look at the other 2 sets of angles that have the same reference angle. And I feel like we should do the other one that has, let's do the other one with the same values. So the angles that are like pi/6, sorry, pi/3. So let me be consistent here. So now we want to look at angles whose reference angle is 60 degrees, which is equal to pi over 3 radians. I do apologize. I'm 20 minutes in and I'm already pretty sure this is going to go a little bit long, but it's important. So let's go ahead and do the same thing. So we're going to draw now a 60-degree reference angle, and I'll try and do it. Again, it's not exactly right. I'm trying to be fairly consistent here. That looks like it's about 60 degrees. And so again, I'll draw my 60 degree, or my 30, 60, 90 triangle again, but I'll draw it in the orientation that makes more sense here. Not required, I just find it helpful. So here I want my short side to be 1/2. Oh, I should label my angles. 30 degrees, 60 degrees, 90 degrees. Short side's 1/2, long side is 1, medium side is √3/2. So in this triangle I've drawn, I'm dropping perpendicular here. This point here has an x coordinate. I've gone over 1/2, and a y coordinate. I've gone up √3/2. So for this angle, 60 degrees, I already know the answer. I'm right anyway. Sine of 60 degrees is the y coordinate, √3/2. Cosine of 60 degrees is the x coordinate, 1/2. Tangent of 60 degrees is the y coordinate divided by the x coordinate, which is √3/2 over 1/2, which ends up just being in the square root of 3. Just as a reminder, in case you've forgotten why I'm doing this x and y thing, let me go back just 1 second. So one more time, in the unit circle, oh, I should have labeled these sides, sorry. And this side is 1/2, this side is √3/2, this side is 1, and then here's my other angle up here of 30 degrees. I don't really care about that angle, but I'm gonna label it. So just as a refresher, the reason I'm allowed to do this is because I said, oh, in this right triangle, if I've gone over x and up y, the point on the circle is x comma y, and we can say that sine of theta is y divided by 1, which is just y, which is the y coordinate there. And cosine of theta is x divided by 1, which is just the x coordinate there. It is also correct to say that this point on the unit circle is equal to cosine of theta comma sine of theta, for whatever angle theta happens to be. That's exactly what we're doing. So for example here, back to the page we're on, sorry, 1 second. I'm not going to write it probably, but this point here is equal to cosine of 60 degrees comma sine of 60 degrees, where our angle here is pi over 3 or 60 degrees. All right, let's do the rest of them. And I'm going to try and make this look symmetrical because I try to draw nice pictures most of the time. So my point's going to be like down there. And then we go over because we're smart. Sure, we can be smart about this. Maybe I should have done this ahead of time. Oh, well, yeah. Can't always be so thoughtful. That looks about right. So up over here, that doesn't look exactly perfect, but you know what? It doesn't have to be perfect. Well, now here is an angle right here. So I should say, here's an angle, 120 degrees, whose reference angle is 60 degrees. Drop a perpendicular. So now this point up here has the same coordinate set, except now the x coordinate is the negative of what it would have been. This is a negative 1/2 comma √3/2 for an angle of 120 degrees, which is 2 pi over 3. And we can see that sine of 120 degrees is still positive √3/2. Cosine of 120 degrees is now negative 1/2. And tangent of 120 degrees is negative √3. Okay. We could certainly be talking about cosecant, secant, and cotangent. I'm just kind of making the assumption that if we know how to find the first 3, you know what? We know how to find the reciprocal 3. Don't worry, I won't leave them out completely. All right, 2 more here. Going down to the third quadrant. My angle, 60 degrees. This reference angle here, also 60 degrees. When I write it in radians, it's pi over 3. Drop my perpendicular. You don't really have to drop this perpendicular. So here's where my picture kind of starts to fall apart a little bit. Didn't quite get that lined up exactly right. Oh well, sometimes that happens. This point here, now the x and the y coordinate are both negative, so this is -1/2 comma -√3 over 2. My angle here, of course, is, my reference angle is pi over 3, then I've gone, use green here, sorry, lots of things going here. I've gone a whole pi plus pi over 3, which is 4 pi over 3. So here, theta is equal to 4 pi over 3, or 180 plus 60 is 240 degrees. So sine of 4 pi over 3 is -√3 over 2. Cosine of 4 pi over 3 is -1/2. And tangent of 4 pi over 3, well, same value, but a negative divided by a negative is going to give you a positive. So it's going to be +√3. And you could probably even fill in the last ones without me doing it. So let's actually fill it in and then draw the picture. So we know that for the next angle, whose reference angle is 60, which is 300 degrees. Sine of 300 degrees, well, if I'm in quadrant 4 over here, the y value is negative, so sine should be negative. Cosine of 300 degrees, well, the x value is positive, so cosine is going to be positive, so it's going to be +1/2. And finally, tangent of 300 degrees, well, tangent is going to be negative divided by positive, so it will be -√3. And that would look like, this. Sorry, and apologies for my pictures, which are falling apart just a tiny, tiny bit. Here's another 60-degree reference angle. And then there's the actual angle, which is 300 degrees. I know my picture's a little, okay, it's not the best I've ever done. But so right here, the point would have been +1/2 for the x coordinate, -√3 over 2 for the y coordinate. The angle is 5 pi over 3 radians, or 300 degrees. Cool. Okay, one more special angle. And then I'll have a few more things to say. This is probably gonna go a little long. I know. Sometimes you gotta make long videos. You can watch it at 1.5 times speed. Double speed is a little fast. You can do double, but so the last special angle we have isn't 30 or 60, it's 45 degrees. So we are looking at angles whose reference angles are 45 degrees. Let's just list them right now. Those angles are in quadrant 2, 135 degrees, right? Pi minus, 180 minus 45, 225 degrees, 180 plus 45, and 315 degrees, which is 360 minus 45. Or in radians, pi over 4, and the angles are 3 pi over 4, 5 pi over 4, 7 pi over 4. Let me make one quick observation, or actually remind you of an observation we made in class yesterday. Radians are really nice. If your angle is pi over 6, or 5 pi over 6, or 7 pi over 6, or 11 pi over 6, the reference angle is pi over 6. If your angle is pi over 3, or 2 pi over 3, or 4 pi over 3, or 5 pi over 3, your reference angle is pi over 3. And similarly, if your given angle is some multiple of pi over 4 that is already reduced, if your angle is 3 pi over 4, or 5 pi over 4, or 7 pi over 4, your reference angle is exactly pi over 4. So that's one thing that's really nice about special angles and radians, is how the reference angles are really easy to see. Okay, let's draw this picture here. Keep losing everything. I'm gonna be a little bit more judicious here. I'm gonna try and get this right in the middle. We'll do our best. I didn't actually mean to go past the circle. Oh well, sometimes you go past the circle. And then let's go the other way here real quick. Try and make these perpendicular because they are perpendicular. But we'll see. So cool, looks beautiful. Looks like Nah, I mean, it's not, it's a little off center, but you know, such is life. Sometimes life is a little off center. Okay, so again, the 45, 45, 90 triangle, one more time, with a hypotenuse of 1. So the hypotenuse is 1, each of these sides is root 2 over 2. So if we drop this perpendicular here, my reference angle is, of course, 45 degrees. My angle is, of course, 45 degrees. And the coordinate, well, the x coordinate is root 2 over 2. The y coordinate is root 2 over 2. And that's my favorite thing about 45 degrees, or any angle whose reference angle is 45 degrees. The x coordinate and the y coordinate are the same, except they might change. They might differ in signs. So we have our angle of 45 degrees, or pi over 4 radians. Let's label the rest of the angles. In fact, let's label everything before we find any sine or cosines or tangents. So here, x coordinate's negative, so my coordinate here is negative root 2 over 2, comma root 2 over 2. Down here, both x and y are negative, so it's negative root 2 over 2, comma negative root 2 over 2. And finally, over here, x and y, well, x is positive, it's positive root 2 over 2, y is negative. Angle over here is 135 degrees, or 3 pi over 4 radians. Down here, the angle is 5 pi over 4 radians, or 225 degrees. Down here, the angle is 7 pi over 4 radians, or 315 degrees. Also, the hypotenuse is the length of 1, right? That's always, always, always the case. That's why it's called the what? I heard you all say unit circle. It's the unit circle, right? The radius is 1. Okay, so I think you should all take a minute to think about what sine and cosine and tangent are going to be for each of these. So for 45 degrees, sine of 45 degrees is going to be root 2 over 2. Cosine of 45 degrees is going to be root 2 over 2. And tangent of 45 degrees, I don't want to write it all out. I want to observe that tangent of 45 is going to be y divided by x, but since y and x are the same, any number divided by the same number is going to equal 1. Okay, except for 0. 0 divided by 0 is totally undefined. Anything else, 5 divided by 5, pi divided by pi, 2.7 divided by 2.7, a billion divided by a billion, they're all equal to 1. So tangent of 45 degrees here is going to be 1. And then for 3 pi over 4, sine of 3 pi over 4 is going to be positive root 2 over 2. Cosine of 3 pi over 4 is going to be negative root 2 over 2. Tangent of 3 pi over 4 is going to be negative 1. Because you have a positive divided by a negative, but they're still the same value regardless of the sign, or ignoring the sign, I guess I should say. Okay, 2 more. Down here, sine of 225 degrees is negative root 2 over 2. Cosine of 225 degrees is also negative root 2 over 2. And tangent of 225 degrees is positive 1. And lastly, sine of 7 pi over 4 is negative root 2 over 2. Cosine of 7 pi over 4 is positive root 2 over 2. And tangent of 7 pi over 4 is negative 1. Okay, 35 minutes. I'm going to say kind of one more thing, and then we'll probably call it a day. Okay. So the big story here is that you can use the unit circle to find sine, cosine, tangent, and also cosecant, secant, and cotangent of any of our nice special angles. So for example, if I said, sure, I'll do this. If I said, find all 6 trigonometric functions of theta equal to, sure, let's go with, let's say 4 pi over 3. There's a number of ways to think about this. Here's the way I would think about it. Okay, 4 pi over 3 is a little bit bigger than pi. It's going to be in quadrant 3. It'll look vaguely like this. And my reference angle, which is measured to the x-axis, is going to be pi over 3, or 60 degrees. I don't really need to drop this perpendicular anymore, although you can. It's not a crime. But what I really need to think about is what this point is here. Well, that point here, this angle, this is the bigger of the two angles, right? There's pi over 3 and pi over 6. And pi over 3, or the 60-degree angle, is the larger angle. So this point here, this side is the smaller side, this side is the larger side. This is -1/2. This is -√3/2. I'm going to do this twice because there's another way I want you to think about this. So if I want to find all 6 trig functions, well, I'm going to say that sine of 4 pi over 3 is equal to -1/2. Cosine of 4 pi over 3 is equal to -√3/2. Oops, I got those backwards. I'm so sorry. That is a terrible mistake, right? Cosine is the x coordinate, sine is the y coordinate. How do you keep those in track? How do you keep track of those? They're alphabetical. X comes before y, and cosine, the letter C, comes before sine, the letter S. Sometimes we write them, but we write them in this order, so it's easy to get them mixed up. So I apologize greatly for that. You can cross that out and start again. Sine of 4 pi over 3 is equal to the y coordinate, which is -√3/2. Cosine of 4 pi over 3 is equal to the x coordinate, which is -1/2. Tangent of 4 pi over 3 is the y coordinate divided by the x coordinate, which is one reason we do write sine first and cosine second, so we can be like, oh, this divided by this gives you tangent. So you get -√3/2 divided by -1/2, which is going to be positive √3. And then for the other 3, you should just use the usual trick of using reciprocals. So cosecant of 4 pi over 3 is -2/√3, which rationalizes as -2√3/3. And secant of 4 pi over 3 is -2. And cotangent of 4 pi over 3 is positive 1/√3, which rationalizes as √3/3. That's one way of doing it. You can certainly memorize the unit circle, know where everything is, and it works out fine. Here's another way of doing it. I'm going to use a regular piece of paper instead of this. I'm not going to use this graphic piece of paper. I'm not sure what to do that. So here's another way of evaluating the trig functions of a single angle. So let's say I want to find, again, 6 trig functions of 4 pi over 3. Step 1, reference angle. I know it's pi over 3, which is equal to 60 degrees. Cool, I'm going to draw the triangle. So 1, reference angle, 2, appropriate triangle. I always draw the angle that I want to be working with in the lower left-hand corner. That's just a matter of habit. And then use whichever version of this triangle you like. You do not have to use the one where the hypotenuse is 1. You certainly can, or you can use the one that maybe you're more comfortable with, where the hypotenuse is 2. You might use that one instead. I would use that one instead. And then think about the quadrant we're in. So 4 pi over 3, well, pi over 3 is in quadrant 1. 2 pi over 3 is in quadrant 2. 3 pi over 3 is pi. It's not actually in any quadrant. It's like it's the break point between quadrant 2 and quadrant 3. And 4 pi over 3 is in quadrant 3. And in quadrant 3, down here, you know that x is negative, so cosine is negative. And you know that y is negative, so sine is negative. So sine and cosine are both going to be negative, and tangent's going to be positive. So now if I want to find all the things, I can say, okay, well, great. Sine of 4 pi over 3, well, it's going to be opposite over hypotenuse, √3/2, but it's going to be negative. Cosine of 4 pi over 3 is going to be adjacent over hypotenuse, but it's going to be negative because quadrant 3. And tangent of 4 pi over 3 is going to be opposite over adjacent, and it's going to be positive because both sine and cosine were negative. Or another way to think about it is one of them, at least one of them always has to be positive. 2 are negative, 1 is positive, unless you're in quadrant. And then the reciprocals, which I don't think we really even need to talk about. Cosine of 4 pi over 3 is -2 root 3 over 3. Secant of 4 pi over 3 is -2. Cotangent of 4 pi over 3 is negative. Not negative. Reciprocals don't change signs. +1 over root 3, which is +root 3 over 3. Okay, so where are we at? We're at 41 minutes. All right. Oof. Okay. You can do this whatever way you like. You can totally memorize, whoops, that's upside down. You can totally memorize where things are on the unit circle, draw the whole unit circle and all that jazz. If you're a fan of memorization, what I would maybe suggest instead of memorizing or reproducing the entire unit circle is being able to reproduce just the first quadrant. In fact, let's go ahead and do that. So you might be, let's draw this. So, okay, here's what I would suggest. If you want to memorize things, here's what I would memorize. And don't be perfect. Oh, it's a little, okay. So here are my angles, my 30-degree angle, my 45-degree angle, and my 60-degree angle. And for my 60-degree angle, I know that the x-coordinate is small and the y-coordinate is big. That's my 1/2 comma root 3 over 2. For the 45-degree angle, I know the values are the same. That's going to be both root 2 over 2's. And for my 30-degree angle, I know that the x-coordinate is larger than the y-coordinate. So it's root 3 over 2 for x, 1/2 for y. Just as a reminder, this is theta equal to 30 degrees. For the middle one, that's theta equal to 45 degrees. And for the blue one, that's theta equal to 60 degrees. Pi over 3, 4. Okay. So if you memorize all those three, then you can certainly just flip them around to know what the other three are. So like, for example, if I said, what's sine of 5 pi over 3? Well, I know sine of pi over 3 is root 3 over 2. That's because of the reference angle is 60 degrees or pi over 3. But then I know that 5 pi over 3 is an angle in quadrant 4. In quadrant 4, the y values, aka the sine values, are negative. So because my angle is in quadrant 4, I'm getting a negative value there. That's a perfectly fine way of doing it. Or you can draw the triangles. Like really, there's like a lot of ways you can do this. Okay. Last thing I want to say about the unit circle today. Not the last thing ever, just for today. And again, I know this is long, but you've got a whole Saturday and Sunday to watch it. So you can just break it up into 2 bits. So the last thing about the unit circle is the unit circle allows us to find sine, cosine, tangent of some angles that don't have reference angles. What do I mean by this? I mean something like, well, again, unit circle radius of 1. So this angle right here, right, that point right there is the point 0, 1. And the angle there is 90 degrees, aka pi over 2 radians. And so if I just apply the same logic that sine of theta is the y-coordinate, cosine of theta is the x-coordinate, tangent is y divided by x, look what happens. Sine of 90 degrees is the y-coordinate, which is 1. Cosine of 90 degrees is the x-coordinate, which is 0. Tangent of 90 degrees, prepare for disappointment, is the y-coordinate divided by the x-coordinate, which is 1 divided by 0. Uh-oh, that's undefined. So tangent of 90 degrees is undefined. Let's look at the other three as well. Cosecant of 90 degrees is the reciprocal of sine of 90 degrees, which is 1 over 1, which is 1. Secant of 90 degrees is the reciprocal of cosine, which is 1 divided by 0. That's also undefined. Finally, cotangent of 90 degrees, instead of being y divided by x like tangent, it's x divided by y, which is 0 divided by 1. And 0 divided by not 0 is just 0. So we can do what's called find the trig functions for quadrantal angles. So quadrantal angles are angles that don't lie in any quadrant, or actually that terminate on an axis. So quadrantal angles are any multiple of 90 degrees or pi over 2 radians. So the typical ones are 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. Obviously, you can keep going 450, 540, 630, 720, 810, and so on and so on and so on. Or in radians, 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. So when I label the unit circle, and I'm thinking, oh yeah, my unit circle, radius of 1, angle theta, and this point here, x comma y, where I've gone over x and up y, is really equal to cosine of theta comma sine of theta. Well, that's true no matter what the angle is. So if my angle is 0 radians or degrees, and the point here is 1 comma 0, that means cosine of 0 radians is just 1. Sine of 0 radians is just 0. Or up here, where the angle is pi over 2, and the point is 0 comma 1, cosine of pi over 2 is 0, and sine of pi over 2 is 1. Or over here, when the angle is pi, and the point is -1, 0. Actually, let me just fill this in here. Or this point here, the angle is 3 pi over 2, and the point is 0, -1. And here the angle could be 0 radians or 2 pi radians. Looking at pi, sine of pi is just the y-coordinate. Cosine of pi is just the x-coordinate. Tangent of pi is just the y-coordinate divided by the x-coordinate. 0 divided by not 0 is 0. Cosecant of pi, if you take the reciprocal of 0, dividing by 0 is undefined. So I would just write cosecant of pi is undefined. Secant of pi is 1 divided by -1, which is -1. And cotangent of pi would be -1 divided by 0, which is also undefined. All right. I think I've said more than enough. I'm sorry the video is so darn long, but I felt like there were a lot of important things to say. So please do watch it. I hope you've watched it. I hope you've gotten to the end. Congratulations, you did it. I'll see you all on Monday, where we'll definitely have lots and lots of stuff about the unit circle to talk about, or to do practice problems on. And again, last thing I'll say here is, it doesn't matter which way you do it. You can totally draw the unit circle, right? You can, sorry, let me go back here just a little bit here. You can totally do this kind of thing where you say, okay, my angle is this, draw the angle on the unit circle, and then find the coordinates. Or you can do this thing where you say, the angle is this, find the let me make it a little more easy to see. Find the reference angle, draw the triangle for that reference angle, think about the quadrant you're in, and then find the values and the signs based on the triangle and the quadrant. Either way of approaching it is fine. We do have to be able to think about this idea of the coordinates being the points on the unit circle, being the sine and the cosine and sine values, because that's the only way we can find sine and cosine of these quadrantal angles, by saying, oh yeah, 90 degrees, there's still a point on the circle for that. And at 90 degrees, the x-coordinate is 0, meaning the cosine value is 0, and the y value is 1, meaning the sine value is 1. So that's the gist. Hope you all have a lovely weekend. Please watch the video. I know it's dumb that, right? What's the point of saying watch the video at the end? But I'm saying it anyway. Please have watched the video. Thank you for watching the video. Bye.